This is lesson 10.3, solve quadratic equations by graphing. You should be on page 643. A quadratic equation is an equation that can be written in the standard form ax squared plus bx plus c equals 0, where a is not 0. Now, we have worked the last few days sketching this, okay? The sketches, we have an idea of what the graph would look like. Now, in Chapter 9, you used factoring to solve equations of these kinds. So when you look below here, solve by factoring, x squared minus 6x plus 5 equals 0. Let's review the steps for this. First, do we have a common factor? GCF. And no, I don't. Is there a shortcut? Is this a perfect square trinomial? Well, 5's not a perfect square, so there's no shortcut. So I got to figure out what times what's 5, but adds up to negative 6, and negative 1 times negative 5 is 5, but negative 1 plus negative 5 is negative 6. So here's my proper factoring, which means the answer to this problem would be 1 or 5. Now when you factor, we don't want to forget factoring, and I told you that for the following reasons. There are some advantages to factoring. First, it's a method that you can use without a calculator. Like I can factor without a calculator. All right, I do have to have some mental math, but I can do this without a calculator. Here's another reason that there's an advantage to factoring. You have work supporting your answer. So, for example, if you go on next year to geometry and Mr. Keller says, here's a problem, I need you to solve this, no calculator, and I need you to show your work, factoring would hit all those things. Factoring does have some disadvantages. Obviously, your mental math has to be strong to execute it quickly. And another disadvantage of factoring, it doesn't necessarily work on all quadratics, okay? Again, if I can't figure out what times what's 5 and adds up to negative 6, I might not be able to have an answer. So there is another method to solving a quadratic. We can also graph it. Now, when we say graph it here, that means we're using a graphing calculator. Notice that the solutions of the equation ax squared plus bx plus c equals 0 are the x-intercepts of the graph of the related function. So here's what they're trying to say. When we do this problem by factoring, the answer is 1 or 5. If we do this problem by graphing, let me do that on my calculator real quick. So I'm doing y equals x squared minus 6x plus 5. When I hit graph, do you notice my graph is crossing the x-axis at, let me move this out of the way, it's crossing at 1 and 5. You notice I'm getting the exact same answers that I got when I factored. Where my graph crosses the x-axis would give me the same answers as my factoring. So you might be thinking, wow, is that easy? All I got to do is type it in my calculator and see where the graph crosses the x-axis? And yes, that's how easy it is. Okay? Now, what are the advantages of graphing to solve a quadratic? Well, one advantage, as you just learned there, it's super easy. You just plug the equation in your calculator. Instead of 0, you would just use y. So you'd use y equals x squared minus 6x plus 5. You'd hit graph, and you'd just see, here's a picture in the book, you would just see where the graph crosses the x-axis. You can see 1 and 5 matches here. So that's great. It's easy. Okay. Here are the disadvantages of this method. You got to be able to use a calculator in order to do that method. So, think about the PSAT a couple weeks ago. There was a non-calculator part. You couldn't use this method on a non-calculator part. Here's another disadvantage. What if you are asked to show work to support your answer? This method doesn't have any work to it, so that's another downside. And there's a third disadvantage to this. It won't necessarily give you exact answers, but let's be honest, this is a huge perk. It's super easy. To solve a quadratic equation by graphing, you have to make sure the equation is in standard form. So this is saying we need to get everything on one side, 0 on the other. That's what this in orange is saying. Same as we did when we factored. Got to get everything on one side, 0 on the other. Then you graph the related function. So let me cover, which means put this in your calculator. Okay, uncover that. So graph the related function, just type it in your calculator. And then the x-intercepts of the graph are the solutions or roots of the problem. Okay, so pretty basic. Let's do another one together. Let's solve this by graphing. This problem, and you can see here in the book, it says it's going to have 2 solutions. Okay, we'll see why. All right, let's solve by graphing. Now, do you notice, do we have everything on one side, 0 on the other? First thing we got to do is take away 3 from each side, which would give me this. Now I can type that in my calculator. Let's do that. And I'm going to do that here, x squared minus 2x minus 3. And then I'm going to hit graph. And when I hit graph, you can see right now, you can see right now that, let me pause this. You can see that we have 2 solutions. One is here at positive 3, and one is here at negative 1. Okay, so x would equal 3, x would equal negative 1. Now, sometimes you might have to verify that. You can verify that by making a table. Let me go to table. Do you notice on my table, when x is negative 1, y is 0. That is definitely an x-intercept, so that would be one solution, and 3, 0 would be the other. So if you're not 100% sure by the picture that that's the x-intercept, just go to your table, and the x value would have to give you 0 for y. So negative 1 and 3 definitely give me 0 for y. Those are my solutions. Okay? Let's do another question. Let's solve this by graphing. So again, you notice here, I got to get everything on one side, 0 on the other. Take away 1 from each side. That gives me negative x squared plus 2x minus 1 equals 0. Let's go ahead and type that in our calculator. So negative x squared plus 2x minus 1. Let's go ahead and hit graph. And it looks to me like I have, it looks like this problem is only intersecting the y-axis in one place. It looks like I only have one answer to this problem, and it would be positive 1 for x. Let's check that on my calculator. Let's go to a table and see if that's the case. And yeah, you can see it right here. I only have one solution to this problem. It's right here. When you plug in 1, you get 0. In other words, that's the vertex. That's the maximum height of the problem, 0. Okay? So there are questions that will only give you one answer. This would be a problem that has one solution. The parabola only touches the x-axis in one place. So I hope this makes sense. If your parabola touches the x-axis in 2 places, you get 2 solutions. The parabola in the previous problem just touched the x-axis in 1 place. That means you get 1 solution. Let's look at this question. Here's a problem where the parabola would give you no solution. Solve this by graphing. So first step, we got to make sure that we take away 4x from each side to get everything on one side, 0 on the other, which gives me this. Okay, let's go ahead and take our graphing calculator and type that in. Okay, so x squared minus 4x plus 7. Okay, go ahead, hit graph. And you notice my parabola is never touching the x-axis, which means for this particular problem, we have no solutions to this problem. There isn't any value for x that will make that statement. Here it is in my calculator. There's no value that I can plug in for x that will make this work out to 0. So with that said, when you look at your graph on your calculator, 3 things can happen. You might want to write these down. If your parabola touches the x-axis in 2 places, you get 2 solutions to the problem. You can see that scenario here. If your parabola touches the x-axis in only 1 place, 1 x-intercept, that means you only get 1 solution. And if your parabola just does not touch the x-axis at all, no x-intercepts, you have no solutions to that problem. Why don't you pause the video right now and try plugging in these 3. Remember, make sure you get everything on one side, 0 on the other before you plug them in. Pause the video and try that. We're back. Here's what you should have found. For question 1, you should be getting, this is wrong, positive 4 and positive 2. Positive 4, positive 2 for your solutions. Okay? Number 2, you should have no solution. The parabola never touched the x-axis. And then number 3, the parabola only touched the x-axis in 1 place, x equals 3. You only get 1 solution here. So again, here, number 1, your parabola should have touched in 2 places at 4 and 2, no solution in 2, 1 solution 3 in question 3. Finding zeros of a function. Because a zero of a function is an x-intercept of the function's graph, you can use the function's graph to find the zeros of a function. In other words, that's a fancy way of saying, if you type this in your calculator, for this sample here, if you type that in, this is saying the 2 points where we touch the x-axis, those would be called the zeros of the function. Those are the values that make this statement work out to 0. So let's actually plug that one in too. Okay, I just went ahead, I plugged it in, I hit graph, and you can see, just like the book has, you can see my 2 solutions. One solution is here at positive 1, right here, and 1, 2, 3, 4, 5, 6, 7. The other solution is negative 7. And let me just double check that on my table. I want to make sure 1 and negative 7 actually give me 0. Well, okay, there's 1 giving me 0, and does 7 give us 0? Oh, I'm sorry, it's negative 7 I meant to say, 1 and negative 7. Got to go back to negative, there it is. Negative 7 you can see gave me 0. I just went right by it. There it is. Okay? So negative 7 and 1 would be my solution. As I said earlier, one weakness of this method is these can't always give you the exact amount, which gets me to approximating a zero of a function. The zeros of a function are not necessarily integers. Remember, integer means no fraction, no decimal. You might get fractional amounts or decimal amounts. To approximate zeros, look at the signs of the function values. If 2 function values have opposite signs, then the 0 falls in between the x values that correspond to the function value. So that might be like, that is totally losing me. So it's actually easier to show on paper or on my calculator. Let's approximate this function to the nearest tenth. Okay, so we're going to type it in our calculator first, x squared plus 4x plus 1. So I'm doing that, x squared plus 4x plus 1. I'm going to graph it. Now, do you notice my answers for this? It looks like one answer is 1, 2, 3. It looks like it's in between 3 and negative 3 and negative 4, and the other answer looks like it's in between maybe 0 and negative 1. I'm going to have to use my calculator to approximate these. So this is how I do it. I got to go to my table. So I turn my table on. Now, do you notice? When you go to your table, I said one answer is in between negative 3 and negative 4, and this is what the book was trying to show you. Do you notice how the y values go from positive to negative right here? I'm going to highlight it. Y went from positive to negative. That means one of my answers is stuck in between here. It's in between -3 and -4. Okay? Here's my other answer. Remember how I said my other answer would be between 0 and -1? Well, look carefully at my table. Do you see how the y's went from negative to positive? There's another answer somewhere between 0 and -1. I need to approximate this to the 10th. Here's how you change your calculator to get that to happen. Go to your table set key. It's right above window. Hit second table set. I know one of my answers is in between -4 and -3. So start your table at -4 and change your, this little triangle means interval. Change your interval from 1 to a 10th. This will approximate things to a 10th. Now go to your table. Do you notice how right here at -3.8, my y values go from positive to negative? That means my answer is actually in between -3.7 and -3.8. Do you notice how this number is closer to 0? I'll put a little note. This is closer to 0. Okay? The y value closest to 0 will give you the x approximation. The answer, I'm going to approximate, one of my answers is about -3.7. Okay? Let's get the other answer. Now remember, the other answer was in between -1 and 0. So let's go to table set, and let's change my table to start at -1. Let's go back, and let's see, where do those y values go from negative to positive, because that's going to show me where my answer is at. Oh, it's right here. Okay? My y values went from negative to positive right here, which means my answer has to be one of these two. I'm going to pick whatever one's closest. You see how that number is closer to 0 than 0.24? That means the other correct approximation would be about -0.3. So my two approximations for this would be -0.3 and -3.7. I just approximated those to the 10th. And if you look in the book, there, that is matching what I just said right there. That -3.7 and -0.3 would be the approximations for this. Why don't you try number 5? Put this in your calculator and try approximating this to the 10th. Okay, you're back. It looks like -0.7 and +2.7 should be your correct approximations. So if you are not getting this, make a little note here and you come in class tomorrow and make sure we talk about, I'll show you on the calculator why these are it. Okay? Now, vertical motion, which is normally a pain, the calculator method's great for vertical motion. An athlete throws a shot put with an initial vertical velocity of 40 feet per second as shown. You notice they're tossing the shot put from a height of 6.5 feet. Write an equation that models the situation. Well, here's V. 6.5 is the starting height, so we put starting height, we put that in for V. There's my equation. The shot put lands, I want to find the amount of time the shot put is in the air. Well, it lands when h is 0, so I need to solve that. Well, easy. Put it in your calculator, -16t squared plus 40t plus 6.5. And you can see I just entered that in. I got to use x, of course, not t. I'm going to hit graph. And I'm going to get two solutions. Now you notice one solution looks like it's going to be negative. I'll throw that one out. But here's the solution I'm interested in. It's the one right here that I'm kind of circling. It looks like it's between 2 and 3. Okay? Let's figure out what that is. It looks like something between 2 and 3. So I'll go to my table set. I'll start my table at 2. And let's just find out, where do those y values go from positive to negative? Oh, right here. Okay? So my answer has to be one of these two. And which of these y values is closest to 0? Well, 2.14 is closer to 0 than 2.34, so the correct approximation would be that. So the answer to the problem is the shot put was in the air approximately, right here, 2.7 seconds. So this works great. The calculator method's perfect for vertical motion model as long as I don't have to show work and I'm allowed to use my calculator. To wrap up the video, there's 3 quick things that you need to understand. The solutions to these are the same things as the x-intercepts, which are the same things as the zeros of a function. So if the directions say find the solution, you can use the calculator method that I just showed you. If the directions say find the x-intercepts, I'm asking you the same thing, just in different wording. If the problem says find the zero of a function, I'm asking you the same thing. This little slide is trying to show you that all of these wordings are asking the same thing. Okay, so when you read the directions, you can't look at this as asking 3 different ideas. They're all asking for the same thing, just in different wording. Finding a solution is the same as finding an x-intercept, which is same as finding a zero of the function. I'm going to pause the video here. If you have questions, make sure you ask during class.